Welcome back. So we'll be talking about mixed numbers in this section. So a lot of times in math, we're not going to be using mixed numbers. Dealing with just fractions is sometimes easier than dealing with mixed numbers. But in the real world, you might say your height in a mixed number, like I am 5.5 feet or something like that. Or if you're cooking, then you need 2 1/3 cups of flour or something like that. So mixed numbers do come up in the real world. So it's good to understand them and be able to work with them, even though going into algebra and calculus and beyond, you won't really be dealing with a whole lot of mixed numbers. So we'll jump right into this one right here, converting 4 2/5 to a fraction. So a lot of times we'll need to do this. We'll convert a mixed number to a fraction in order to more easily do some math with it. So 4 2/5 is the same thing as saying 4 plus 2/5, right? Just even the way you say 4 2/5. Using the word and usually means plus, 4 2/5. So it's the same thing as saying 4 plus 2/5. Well, 4 would be the same thing as what? It would be the same thing as, let's say, 8/2. That's one example of 4. But we want a denominator of 5. So 4 is also equal to 20/5, right? Because 20 divided by 5 would be 4. So it's the same number. They both represent the number 4. So let's go ahead and swap that out, because now we can actually add these two. So if we have 20/5 plus 2/5, and that would be 22/5. So basically you just create a fraction with the common denominator and then you can add them. So the way I typically think of it is I do a sort of an upside down C. I start from the bottom and go off to the side and then to the top. That's how I think of it. But basically I do 5 times 4, so it'd be times here and then plus here. So 5 times 4 is 20, plus 2 is 22, which is the same thing as what's going on right here. This is just a way for me to remember how to do this quickly. So 5 times 4 plus 2, it'd be 22/5, and that's our fraction. Okay, now we're going to go the other way around. We're going to convert 7/2 to a mixed number. Let's see what we can do here. So we know that 7 is the same thing as 6 plus 1. So we'll start there. 6 plus 1 over 2 would be the same thing as 7/2, right? Well, we can split this fraction up now. Now, one thing to be careful of, if we had something like, let's say 6 times 3/2, then we could cancel this, right? It would be 3 and 1. Or if you wanted to first split this up, then we could say 6/2 times 3. And then we could say 3 times 3, and it would be 9, right? But when we split up fractions when we're adding, that's with multiplication, and you can kind of just take out a part of the numerator there. You cannot do it with this. So this is not the same thing as saying 6/2 plus 1. You cannot do that. Because this denominator applies to both of these numbers. So you can split the fractions up, but be careful the way you do it. You do not do it like this with addition. You do it like this. You do 6/2 plus 1/2. Okay? So this is the proper way to split fractions when you have addition. So be very careful with that you don't accidentally do some canceling or anything like that. Okay, but now we can simplify this fraction. 6/2 is just 3 plus 1/2, and that is just 3.5. Okay, so same thing for this one. So basically what we did here, so we had 7/2, and we divided out all the 2's that we could from 7, which was 3 of them, right? 3 2's would be 6, and you'd have 1/2 left over. We do the same thing for this one. So how many 12's can go into 137 without going over it? Well, we know 12 squared is 144. You might have that one memorized. That's too many. You might not have 12 times 11 memorized, but if you don't have it already memorized, then you could use your 11's trick. That I mentioned maybe last chapter, if you do 11 times 12. If you don't remember it, then what you do is you take the first number it becomes the first number. You take the sum of the two numbers, that's your second number. So 1 plus 2 is 3. Then you take the third number, you take the last number, and that's going to be your third number. So 132 is going to be 11 times 12. So, and that is less than 137, so we can use that. So we know that 11 12s is 132, so we know we can pull 11 of those 12s out, and then we're left with how many? We're left with, it looks like 5 left over, 5 twelfths. Because we took 132 out of the 137. All right. Now express each of the following as a mixed number, or the negation of a mixed number. Okay, so 7 plus 3, well, that's just how, 7 and a third. That's just what a mixed number is, so 7 and 1/3. Just write it like that. And also remember that this does not mean 7 times 1/3. 7 times 1/3 is very different than 7 and 1/3, the mixed number 7 and a third. Because this is 7 plus 1/3, not 7 times 1/3. It'd be very different values. Okay, how about 7 minus 1/3? We could go through and convert this to a fraction. We could say 7 is the same thing as 21 over 3 minus 1/3 gives us 20/3. But it says express it as a mixed number, so now we need to convert. Let's see, 3 goes into 20 6 times with 2 left over, right? 6 and 2/3. We could do it that way, and we get the right answer. That is the right answer. But if we just look at this problem and think about it, well, let's say we have 4 pizzas. We have 4 pizzas, and we want to do the problem 4 minus 1/2. Okay, so we have 4 pizzas, and then we want to subtract 1/2 of them. Well, how much do we have left? 1, 2, 3.5. So we didn't really have to do any math there. We just kind of had to think about it. If you cut out a fraction of a whole number, just what part of that last fraction is left? You can basically just say 4 plus, and then just take 4 is equal to 3 plus 1, is what I meant to do. 3 plus 1, and then take the half out of that, minus 1/2. And then, so you've got your 3 still, and then 1 minus a half, you just take the half out of a whole number there, and you're left with another half, so that would be 3.5. You can do the same thing here. So if you have 7 whole numbers, and then you take a third out of that, well, you're going to have 6 and something, right? Because you're not taking a full integer out of 7. You're just taking a fraction out of 7. So it's just going to go down to 6. It's going to be a little bit less than 7, but it's not going to be lower than 6. So if you're taking out 1/3 out of a whole, how much is left in that whole? And that's going to be 2/3. And that's the same answer we got there. Okay, so now what if we have -7 minus 1/3? So one thing to remember is that if you have, let's say, 4 plus 3, well, you can distribute a negation here, or in this case, so this would be, distribute a negation. You can distribute negation. You can also distribute subtraction. That's where I was going with that. But in this case, you can distribute negation. So this would be -4 minus 3. That's a lot like what this looks like right here. So instead of distributing, we can factor out that negation. So -7 plus 1/3. And now we just do our parentheses. We know that's just 7 and a third, and it's going to be negative because we have this negation on the outside. So -7 and 1/3. All right, so if you have a negative integer minus a fraction, it's basically like adding, but it's going to just get more negative. So if it was at -7 and you subtract another third, it's going to be -1 1/3. It's going to be even more negative. All right, what if you have a negative number and then you add a number to it? Well, we could do the same thing we did in the last problem. If you want to factor out a negative sign, we could do that. You have to flip both signs. So if we have a negative outside here, well, now that 7 becomes a positive, and the 1/3 becomes a negative, -1/3. So we flip the signs for both. Well, if we plus a negation, that's the same thing. That's our definition of subtraction now. So that'd be saying the same thing as 7 minus 1/3. And we already said that 7 minus 1/3 is 6 2/3. So now this would equal negative 6 2/3. Right, which sort of makes sense because we start at -7 on the number line. So if you look at a number line, and we have 0 over here and -7 over here, and we want to add a third, we know it's going to get a little bit closer to 0. So it's going to be 6 and something. Let's say -6 is right here. So we know it's going to be in between -6 and -7, and that is what we got. Okay, so now we are adding two mixed numbers together. Okay, so what is 5 3/5 plus 6 1/5? Well, there's a couple different ways to do this. So let's first go ahead and split all this up. So this is 5 plus 3/5 plus 6 plus 1/5. Well, we know addition is commutative, so it doesn't matter what order we add these in. So 5 plus 6, that's pretty easy. That would just be 11. So 11 plus, and then now we have these fractions left. So 3/5 plus 1/5. Well, that's pretty easy. 3/5 plus 1/5 is just 4/5. So now we have 11 plus 4/5, or just 11 4/5. All right, so that's one way to do it, and so I'll show a different way for the next problem. Okay, so another way to do this one here, we could do it the same way, and that's fine. And actually, it would be pretty easy to do it this way. It would be 4 plus 8, and then 2/3 plus 2/3. But let's go ahead and convert these to fractions first. So 4 times, remember my trick here, 4 times 3 plus 2, and 8 times 3 plus 2. So 4 times 3 would be 12, plus 2 is 14/3, plus 3 times 8 is 24, plus 2 is 26/3. Add these together, and we have 40. 40/3. So let's see. 3 can go into 40. Well, I know 39 is a multiple of 3, which would be, well, so 10 3s is 30. And then 3 more 3s would be 39. So that should be 13 3s would be 39. And what are we left with? 1 more third. And would we have gotten the same thing we did the other way? So 8 plus 4 is 12. 12 plus, well, 2/3 and 2/3, that would be 4/3. And 4/3 is just 12 plus 12. 4/3 is 1 1/3. 1 1/3, or 1 plus 1/3. And that would give us 13 1/3. So we get the same answer. Okay, well, how about subtraction? Can we do that the same way? So let's write this out. So we have 8 2/5 minus 3. Oh, is it plus 1/5 here? So this minus actually, this minus applies to the entire fraction, the entire mixed number. So 3 plus 1/5. Very important that you don't forget that. Or you can say that -3 1/5 is equal to -3 minus 1/5. All right, we saw that in the last slide, that right here. So -7 minus 1/3 would be -1 1/3. So if we were to split it up, it would be -7 minus 1/3. Same thing here. So that minus does apply to the entire mixed number. If you forget that, then you do -3 and then plus 1/5, and you get the wrong answer. So anyway, so if we were to now distribute this minus here, we'd get 8. Let's split this up. 8 plus 2/5. Then we have -3 plus -1/5. Or we can just say minus 1/5. Okay. And now, if we want, we could convert this to addition plus negative. And I just converted this to negative, but let's convert it back to addition. So now, since we're adding everything, now we can use the commutative property and add in whatever order we want. So if we add 8 and negative 3, then we would get 5. 8 plus negative 3 would be 8 minus 3, which would be 5. And now we have 2/5 plus negative 1/5, the same thing as saying 2/5 minus 1/5, and that would be 2 minus 1 would be 1. All right, so we could have done 8 minus 3 would be 5, and 2/5 minus 1/5 would be 1/5. That's a faster way to do it. All right, so let's see about this one here. We have 6 minus 8. Looks like our whole number is going to be negative. So negative 2. And then our fraction is going to be 4/7 minus 2/7. So that's going to be plus 2/7. Okay, so if we're adding a fraction to a negative whole number, let's see, what's the easiest way to think about this? We could extract that negative sign and just flip our signs. We can say negative, then we have positive 2 minus 2/7. Right? And if you take 2/7 away from a whole number, well, how many sevenths are going to be left? There's going to be 5 sevenths left from the whole number. So it's going to be, don't forget your negative sign here, negative 1, right? Because we took away from that 2. So because we're taking a fraction away from that 2, then we're down to 1. And how much of that fraction is left from that 1 we took away from? There would be 5 sevenths left over. So that can be a little bit trickier. So maybe we'll break it down a little bit more for this one. And does it make sense? So if we start at 6 and 4/7 on the number line, and then we're going to take away 8. So we take away 8, we would be down to negative 2 and 4/7. And then we take away another 2/7. I'm not sure that's right. Okay, let's go ahead and split this up. 6 plus 4/7 minus 8 minus 2/7. Okay, and then we can convert to addition. And then we can do, let's do negative 8 plus 6. It would be negative 2. Or yeah, you can do 6 minus 8, whatever you prefer. And then we have 4/7 minus 2/7 would be 2/7. Okay, so this was not right. Glad I redid that again. So this would be, oh, sorry, I'm not done yet. Plus 2/7, that was right. That's the same thing I got here, right? Negative 2 plus 2/7 is right there. All right, and then so we have to add a little bit more. We have to add that 2/7 to our negative 2, which would give us negative 1 and 5/7. Okay, so that was right. And the way we got from here to there was, I already worked that out. All right, hopefully that makes sense. Okay, some more practice. So 12 and 2/3 plus 9.5. All right, so we have different denominators here. Makes it a little bit trickier, but we know we can add the integer part. So 12 plus 9 would be 21 plus 2/3 plus 1/2. Well, we learned in the last section how to add fractions with different denominators. So that's going to be 21. So we got to find a common denominator. So I think 6 would work. So 2 times 2 would be 4. 4/6. And multiply top and bottom by 3. So that'd be 3/6. And that'd be 21 plus 7/6. We know we can simplify that. We can take a whole number out of that and be 22. And what's left? 1/6. Okay. And this next one. So again, we can subtract the integer parts. So 18 minus 6 would be 12. And we have plus 1/2. But remember, this is a minus 6 minus 5/6. So there's going to be minus 5/6. Okay. And if we were to break this down, we have 18 plus 1/2 minus 6 minus 5/6. If we wanted to convert to addition, we could do that. That way we can use the commutative property and do 18 plus negative 6, which would be 18 minus 6, which is what we got here. And then 12 plus negative 5/6, which is the same thing as saying, what did I say, 12? 1/2 plus negative 5/6, which is the same thing as saying 1/2 minus 5/6. That's what we have here. Okay, so let's get a common denominator. So we have 12 plus, you can do 3/6 minus 5/6. It's going to be a negative fraction there. So we have 12 plus negative 2/6. That's the same thing as minus, plus a negative is minus, but also 2/6 can be simplified to 1/3. So 12 minus 1/3. So what is 12 minus 1/3? That's a minus there. Well, if you take a third away from an integer here, then you're going to go down to 11 and have 2/3 left of that integer. So 11 2/3. Okay, let me just check my work, make sure I got the right answer. 4.51. 11 2/3. Yep, and 22 1/6. All right, so what is 3 times 4 or 3 times 4 3/5? Okay, so what doesn't work here is just multiplying the integer parts, keeping the fraction. So if we were to first convert this to a fraction, we convert this mixed number to a fraction, we can see what the answer should be. So again, 5 times 4 plus 3, we'd have 3 times 4 times 5 is 20, plus 3 is 23 over 5. And so now we know how to do this. Now we just do 3 times 23, and 3 times 23 would be 69 over 5. We can convert that to a fraction. So let's see, we know 10 5s is 50. 3 more 5s to get to 65. So we're at 13. And there would be 4/5 left. Okay, so we know the answer should be 13 4/5. So that means we can't do 3 times 4 is 12. So because that'd be 12 3/5. So that's not right. So we do need to make sure that we are doing these properly. And I think the easiest way to do that is just convert it to a fraction first, and then you can multiply it. So another way that you could have done it is, if you remember that 4 3/5 is the same thing as saying 4 plus 3/5. Well, just like we did, let's say negative 4 3/5, just like we did the negative, we knew that the negative had to apply to this whole thing. So that's the same thing as saying negative 4 plus 3/5, or negative 4 minus 3/5. Just like that. The same thing applies here. So when you say 4 plus 3/5 here, and then you multiply a number, so it's going to be 3 times 4 3/5. So now you know you can distribute. So that would be 3 times 4 is 12. 12 plus 3 times 3/5. This is not 3 3/5, it's 3 times 3/5. So this would be 12. It's supposed to be a 12 here. Not great handwriting. 12 and 9/5. And 9/5 would be 1 4/5. So that would give us 13 4/5. So that way it works also. All right, so whichever you prefer. So let's see, we have 4/5. So in this case, I think it does make more sense to convert it to a fraction first, because I don't know if it would make a whole lot of sense to say 4/5 times 2 plus 1/2, because now you need to go and distribute a fraction. It might be easier to just go ahead and convert this to a fraction here. So 2 times 2 plus 1, we have 4/5 times 2 times 2 is 4 plus 1 is 5/2. And now fraction multiplication is easy. 4 times 5 is 20. 5 times 2 is 10. We can cancel out zeros, and this is going to be 2. Okay, how about 7 1/3 divided by 2? So this is going to be 7 1/3 times 1/2. So yeah, that might be easier to convert again. So 7 times 3 plus 1 would give us, 7 times 3 is 21, plus 1 is 22. So 22/3 times 1/2. So before we do this, remember to simplify when you can, make this problem easier. So I see 22 and 2 here. So it's going to be 11 and 1. And I haven't done it in that way before. What I've done previously is something like, I will combine them first. I'll say 22 times 1 over 3 times 2. And then I would say, well, multiplication is commutative, so we can change the order. Now we can say 1 times 22 over 3 times 2. And if we want, we can split these fractions up, and then we could say 1/3 times 22 over 2. And now we can see that that's 11. So I did all these steps before, but really it's just doing this. So this is kind of a shortcut way of doing it. You can kind of just cross cancel like that. And that still gets you the same answer. And to prove it, so this would be 22 over 2 would be 11, and there would be 11/3. And same thing here. We multiply 11 times 1 would be 11 over 3. No, that's not quite our answer yet, because this is in terms of mixed numbers. We want our answer to be in terms of mixed numbers. How many 3 goes into 11? 3 3s would make 9, and would give us 2/3 left over. So that would be our mixed number. So I'll be using this trick going forward from now on, since we kind of know the math and we know how we're allowed to get there. Okay, between what two consecutive integers is 1603 over 80 minus 62 over 7? Okay, interesting. So we know that 1600 would be 20 80s. So this is a little bit more than 20, right? Because 1600 over 80 would be 20. So this is a little bit over 20. And then minus, so let's see, 9 sevens would be 63. So this is a little bit under 9. All right, so if it was just 20 minus 9, then we'd have 11. But this is a little bit over 20, and this is a little bit under 9. So if we look at that in a number line, and so we have, let's say 20 is right here. And so then we start off a little bit over 20. So we start off like around right here, right? And we take away a little bit. So if we took away a full 9, then we would say, let's say here's 11. Here's 11 right here. If we took away a full 9, we'd be in the same spot, just a little bit over 11. So we'd be, right around there. We took away a full 9. But we're not taking away a full 9, we're taking a little bit less than 9. So we're going to be, a little bit closer to 20. But it's still going to be, but it's not taking away 10. Or rather, it's taking away more than 8. It is less than 9, but more than 8. Because if we only took away 8, then where is 12? So let's say 12 is like right here. Okay, if we took away 8, then we'd be right here. If we took away more than 8, a little bit less than 9, so almost 9 but not quite 9, which means it's going to be in between 11 and 12. All right. Okay, Jen has outgrown her pants and gives them to her sister. The legs of the pants were 25¼ inches long, but her sister wears pants in which the legs are 22½ inches long. By how many inches will her sister have to reduce the legs of her pants to fit them? Okay, so that just sounds like subtraction to me. That sounds like we start at 25¼ but we need to go down to 22½ inches. So we need to subtract 22½ to see what the difference is. Okay, well, we've got the subtraction down, so 25 minus 22 would be 3. And 1/4 minus 1/2, let's see, 3, 1/4 minus 1/2. Well, that'd be the same thing as 1/4 minus 2/4. So now we have 3 minus 1 minus 2 would be -1/4. So it would be adding a -1/4, right? Which would be subtraction. So 3 minus 1/4. You take away 1/4 from an integer here, then you'd be left with 3/4 of that integer. And so that's your answer. And what does this mean? By how many inches will her sister have to reduce the legs of the pants? So we have to reduce the pants by 2 3/4 inches in order to get down to 25. Let's see if that makes sense. So, if we're at 25 and we need to go down to 22, well, we know it's going to be sort of around 3 inches, probably a little bit less than 3 inches. So this is reasonable. If you had a number like, 10 or 20 or something like that, then you know that's not a reasonable answer because you only need to go down a little bit by a couple inches. So that looks like a reasonable answer to me. But that's it for this chapter. So go ahead and do your 4.8 exercises. Check out 4.9, which is the summary of the chapter. This is the largest chapter. I think it's the most number of sections in a chapter in the entire book, and we got through it. So that's good news, and we'll be on to chapter 5 next. So I'll see you then.